In this lab, we measured the force in the spring scale, and that was the tension, and we measured the force in the spring scale that was attached to this cord, and that was T2. And we took a protractor or a level and we measured the angle here, and I'm going to call that theta 2, and we measured the angle here, and I'm going to call that theta 1. And this was our unknown mass. Now to solve this problem, we need to start with a free body diagram of all the forces acting on the knot. So there is a weight force acting on the knot, and that weight force is key to finding the mass, because weight is equal to the mass of the object times the acceleration due to gravity that we derived in class. This was my Ft1 at theta 1. This is my Ft2 at theta 2. So now we need to sum the forces. First, to do this, we need to recognize that each one of these forces, the tension forces, are in both the x and y direction. So this is the x-axis, and this will be our y-axis. I'll make it broken right here just as a reference. So the x component, if I sum the forces in the x direction, the x component of this force, which would be in this direction, is adjacent to that angle. So, and it's pointing to the left. So it would be negative Ft1 times the cosine of theta 1. And then Ft2 has a x component, but it is to the right, so that would be positive Ft2 cosine theta 2, and then that's all the forces in the x direction, and it's balanced so it equals 0. Then we have to sum the forces in the y direction. Now, the y direction here is up. So that is a positive Ft1 sine, because it is opposite of this angle. So there's the angle here, and this is the opposite side. So sine of theta 1. And then we've got this guy right here, and that is also positive. It's up, so it's plus Ft2 sine theta 2. So we've taken care of the components. The component is the part. It's the part of the vector in the x or y direction. So now, so we've taken care of those two vectors. Now there's one vector left, and that is the weight force, and it is only in the x direction. Pardon me, only in the y direction. So it would be a negative gravitational force equals 0. Now in this particular example, let's say that we measure with the spring scale Ft1